Hi, and welcome to Day 5 Notes, our last notes for our unit on stoichiometry. And today we're going to just continue what we talked about yesterday or in the previous note section, and that is how to figure out how much of the excess reactant is left over. So let's take a look at those limiting reactants calculations. Here's our example problem. How many moles of iron 3 oxide can be produced from the reaction of 13.17 moles of iron with 18.19 moles of oxygen? So first thing I need to do is to figure out what is the word equation, then turn that into the formula equation, and then I need to balance that. So here's my word equation. Iron and oxygen will produce iron 3 oxide. My formula equation, in order to figure out what the formula for iron 3 oxide is, I need to be sure to check out the charges on these atoms so that I can make sure my overall compound has a neutral charge or is a charge of 0. So oxygen always has a -2 charge, and iron will have different charges, but it's already telling us that it's iron 3 oxide, so I know that the charge on iron is going to be a +3. So there's my formula. Balance my equation. And now what I'm going to have to do is just go through the steps to figure out what is the limiting reactant in this question. I know I have 13.17 moles of iron, and I'm asked to find how many moles of iron 3 oxide. There's my mole ratio, right from the chemical reaction. And that's my amount of iron 3 oxide that will be produced from the iron I have. Now I need to figure out how much can be produced from the oxygen. This is the same thing we did yesterday. Well, I can get 12.13 moles of iron 3 oxide from the amount of oxygen I've got. So obviously I've got a lot more oxygen needed for this reaction than I do for the iron. So this is not going to be the limiting reactant. The iron will be my limiting reactant. All right, now I think it's almost easiest if you think about, we're just continuing the problem that we just did. We're going to look at a little bit different product or a little different chemical reaction, but this is going to be the same process over again. So this is a nice question because it's really going to ask us to not just give us the moles, but now we're going to convert from atoms, and then we're also going to be converting from liters, since we have the chlorine as a gas at STP, standard temperature and pressure. And then we'll get to part B of our question, how much of the excess reactant reacts and how much is left over. So, get started here. First thing we need to figure out is how many moles I have of cobalt. It's told me how many atoms there are. So I need to figure out how many moles there are and then convert that into grams, because that's what my question is asking for. What is the mass? So I know I have to do a lot of converting in this question. So let's get started. Here's what I know, how many atoms I have. Well, the conversion factor that works for the number of atoms in a mole would be something we're really familiar with, 6.02 times 10 to the 23rd atoms in 1 mole. My units cross out. Now I have to get my mole ratio. I'm to 1 mole of cobalt, go up to my chemical reaction. Well, there are 2 moles of cobalt per 2 moles of cobalt chloride produced. So there's my mole ratio. Cross them out. Now, because I have to go to grams, I've got to find out how much a mole of cobalt chloride weighs. So I'm just figuring out the molar mass right here. So 1 mole would be 165.13 grams. Put that into my calculation. Make sure my units cancel out. Multiply this top together, then divide by the bottom. And the answer you'll get is 95.40 grams of cobalt chloride. Now we just need to do the same thing with our chlorine gas. Now, it gave us this in liters. So this is no different than if it had given us the number of atoms. I have to turn the liters into how many moles are in 57.92 liters. Again, I'm going to need to grab a conversion factor that will still give me the grams of cobalt chloride. Here's what I know. I have this many liters. Well, from our mole chapter, I know that there are 22.4 liters in 1 mole of a gas. Here's my mole ratio. I have 3 moles of chlorine gas to 2 moles of cobalt chloride. Now I need to again figure out, because I need my answer in grams, and I don't have grams here yet. I can consult by 1 mole of cobalt chloride weighs, and I figured that out over here, so I don't need to do any other calculations, just bring this number right on over. Now when I cross off my units, I'm left with grams of cobalt chloride, which is what I needed to find in my answer, and now I'm ready to calculate it. Well, this amount is quite a bit more than this, so this is not my limiting reactant. This would be my limiting reactant. So the cobalt is going to be what's going to stop more of this product from being produced. It's going to run out. And this would be my excess reactant. So let's just quickly go back through, and again, what is the mass of cobalt chloride is formed? We figured that part out. We got that. Now we just need to find out how much of the excess reactant reacts, or how much is used, and how much is left over. My limiting reactant, my excess reactant. Well, I know how many atoms I started with, and I need to find out how many liters of chlorine gas are going to be used up in this reaction. So there's my conversion to number of moles. My mole ratio, 2 moles of cobalt per 3 moles of chlorine gas. One more mole of chlorine gas has 22.4 liters. Now I'm finally to the unit that I need. The only unit that's left over is the one that I need, so I'm ready to put it in the calculator. And that's the amount of chlorine gas that I'm going to use. Same question. To find out how much is left over or unreacted, I just need to subtract the amount of the excess reactant that reacted from the original amount of the excess reactant from the problem. So this is what I had. We just figured out what I used, and I just have to find the difference. So I started with 57.92. I'm using 19.41 liters, which gives me a difference of 38.51 liters. So this is going to be how much is used, 19.41, and this is going to be the amount that's left over. Well, we're all set with our notes, and that was the last note in this series. This was called stoichiometry, and it's a very useful thing. Hopefully you learned some things in the lab activities that you've done, and we'll go ahead and practice with a few more problems, and then we will be ready to